extenders to each Nexus 7000. And then we'll use a Cisco 3750E switch in place of a VMware host that will connect to each fabric extender and create a virtual port channel. Only issue that we are going to run into in this design is when we use a physical switch to simulate VMware virtual switch or VDS, is that these virtual switches don't run spanning tree, and these fabric extenders have built-in BPDU guard feature enabled, which we cannot disable. So it's not designed to connect to a physical switch that runs spanning tree. So in our case, we are going to enable BPDU filter in port channel interfaces on Catalyst 3750E switch, so fabric extenders won't see any BPDUs coming from these interfaces, and allow us to form a virtual port channel by not error disabling the ports. For virtual port channel configuration, we need to set up three components. We need a virtual port channel peer keep alive link, which is a point-to-point layer 3 connection between Nexus 7000s in a separate VRF for heartbeat to prevent dual active or split brain scenario. Second, we need a virtual port channel peer link that synchronizes both chassis control plane for virtual port channel related operations. We are going to configure this as a standard trunk interface between both switches. Third is the virtual port channels that connects to other devices. In this configuration, we are going to utilize 4 modules at each Nexus 7000s. 2 M1 modules, modules 1 and 2 at each Nexus 7000s will let us to configure 2 gigabits per second port channel for VPC peer keep alive. And 2 M2 modules, modules 4 and 7 will let us to configure 40 gigabits per second port channel for VPC peer link, and also another 20 gigabits per second port channel for connect to Nexus 2K fabric extenders. We are going to create new VDCs, virtual device contexts, at each 7000s for this setup. So let's start by creating these VDCs. Okay, so on the first Nexus 7000, let's create a VDC. We'll name it DC N7K1 VDC1. And we'll do the same on the second Nexus 7000. Create a new VDC. Okay, once the VDC is initialized, we'll allocate ports to this new VDC. We allocate those 4 interfaces, 2M1 and 2M2 interfaces, to these VDCs, which are these 4 ports, 4 modules, I should say. And we'll do the same at the second Nexus 7K VDC. Allocate the interfaces, the 4 modules. Let's install the feature set FEX, which I have already installed. Let's do the same on both VDCs. I'm sorry, on both the admin VDCs. And then let's switch into the VDCs that we just created. Let's go through the standard setup. Same on the second Nexus 7K, and you'll pretty much notice that in this configuration we are going to configure both Nexus 7Ks exactly the same. And let's install the feature set FEX on each VDC. And now let's create the port channel for the FEX. Port channel 101, switch port mode FEX fabric. And let's configure that to associate with the 101 FEX associate 101. Let's allocate ports, in our case 412 and 712, which are M2 interface modules. This is the 20 gigabits per second port channel for FEX fabric extender. Switch port mode FEX, and let's assign that to the port channel we just created, 101. You see the FEX came online. Can do show FEX and make sure that it's properly connected to the Nexus 7K. Let's do the same on the second Nexus 7000 VDC. Feature set FEX, interface port channel 101, switch port mode FEX fabric, and FEX associate 101. You see that this 101 is where the kind of like a definition of the module. So each port on this FEX will associate as 101 dash 1 dash 1, like that. Okay, that FEX is online too. Okay, let's install the necessary feature sets for VPC, which are LACP and VPC. Let's create the VRF for the peer keep alive link, and let's configure that point-to-point port channel, layer 3 port channel for VPC peer keep alive, and assign that to the VRF. Let's assign the ports for the port channel. So these are the two M1 modules. Let's do the same on the second Nexus. Feature LACP and VPC is required for VPC configuration. Create the VRF, create the port channel, assign the VRF to the port channel, and configure layer 3 addressing. Let's allocate the interfaces to the port channel. Now let's make sure that the port channel is up between both Nexus 7Ks for peer keep alives. You can see that it's up. Let's do ICMP connectivity test to make sure that we have end-to-end connectivity over that VRF, which we do. Okay, now let's configure the VPC domain 1. Let's create the priority for this one lower, so it becomes the active primary for the VPC domain. Let's set up the VPC peer keep alive destination on that. We do the same on the second one, second Nexus 7K. We are going to use the default role priority, so this will be the secondary on VPC domain. So if you do a show VPC domain, you see the peer keeper link is up, but the peer link is not configured. So we are going to configure the peer link now. That would be our port channel 1, and it's a trunk interface, and we're just going to specify that as a VPC peer link. And you see that it's going to configure the bridge assurance on this trunk interface, which is spanning tree port type network. Let's allocate the 4 interfaces from 2M2 modules for the VPC peer link. Assign those to channel group 1, no shut. Let's do the same on the second switch too. By default, as soon as you put the VPC peer link, it enables the bridge assurance. Alright, so our VPC peer link is up, so let's check the port peer link is configured. Let's check the port channels. They are also up. And let's check the VPC, which is all good. And the role is primary. Okay, let's configure the port channels for the 3750. Port channel 10, let's get VPC 10 on that. Then let's assign the FEX interfaces we just connected, 101-1-1. You can see this FEX numbering. It goes like this, based on the number that you associate with the FEX. So it's going to be 101-1-1, and we are going to add that to the port channel. Let's do the same thing to the secondary switch, the second Nexus 7K, port channel 10, switch port, and assign the VPC for that, VPC 10, and then allocate the FEX interface for that as well, 101-1-1. Okay, so show port channel summary interface port channel 10. Right now they both are suspended. Because we didn't configure the other end. So let's configure this the 3750E switch, which is acting as a VMware host. Remember, we need to disable the spanning tree on these ports. So what we are going to do is we are going to do BPDU filter on that port channel, not to send BPDUs. And assign ports, 10 gig ports to the port channel. Alright, let's check show port channel summary on this switch and make sure that we see the interface just coming up. So it's a channel summary, and you see that the virtual port channel is up right now. If you go back to the other switches, Nexus 7 case, those are in active mode, which was before on suspended mode. Now they are active. We can do some verifications right now. Show VPC will show that the VPC that we just created, 10, up and up. If you check the rule on the primary, you'll see it's the priority that we configured, make it primary. Let's just statistics VPC 10, and you see that the port channel 10 is up, admin state is up, and the status is all good. Show port channel summary, just a recap, all the port channels that we created, 1 and 2, and 10 is our VPC. The secondary, on the second Nexus 7K, same thing. Okay, let's take a look at what happens if we enable spanning tree. Let's go ahead and disable the BPDU filter. Just do no spanning tree BPDU filter, which will enable BPDUs, and you see right away the FEX interface went for BPDU guard and disable the port. And you see that interface, both interfaces are down now. Alright, so this is pretty much for this demonstration. Thank you very much.